Page 711, number 3. A point in polar coordinates is given. Find the corresponding rectangular coordinates of the point. And we're given the point -1, 5 pi over 4. Well, polar coordinates are given as r, theta. So r means this point is 1 unit, actually -1 unit away from the origin, at an angle of 5 pi over 4. Okay, let's make a rough sketch of a graph of this. So if our angle is 5 pi over 4, here's 1/4, 2/4, 3/4, 4/4. Here's my angle, 5 pi over 4. And we're talking about a point that's 1 unit, actually -1 unit away from the origin. Well, if it was +1, I'd put my point out here. But since it's -1, we're going to put our point the other direction, 1 unit away from the origin. Well, let's use this point and the Pythagorean theorem to find the rectangular coordinates. Well, if this value here is 1, what we need to find is this value x, this value y, to get my point in rectangular coordinates, because we know rectangular coordinates are x, y. Well, to find those, we can do it a couple different ways. We know that this is a 45-degree angle, so I could say the sine of 45, I could use the cosine of 45. I also should recognize that this is a special right triangle, 45, 45, 90. So x times the square root of 2 is equal to that hypotenuse, which is 1. Dividing both sides by the square root of 2, I get x equals 1 over the square root of 2, which is the same as the square root of 2 over 2. So my x value is the square root of 2 over 2. Y is going to be the same thing. So my point in rectangular coordinates is the square root of 2 over 2, the square root of 2 over 2, which if I had used sine and cosine and found about 0.7, 0.7, that would also be correct. This is just an exact answer.